Question number 2. A block X slides along a horizontal frictionless surface towards a stationary block Y as illustrated in figure 2.1. So block X moves towards block Y and the block Y is stationary and the surface is a frictionless surface. There is no resistive force acting on block X as it moves towards block Y. At time t is equal to 0, block X has momentum given. So we have given the value of momentum for block X. And what is momentum? So we know that momentum is equal to mass into velocity. Momentum is equal to mass into velocity. A short time later, the blocks collide and then separate. The variation with time for the momentum of block Y is shown in figure 2.2. So for block Y, we have given the momentum against time graph for block Y. So initially, block Y is at rest. So the momentum is 0 and as the two blocks collide, so there is a change in momentum. As the two blocks collide, so a force must act. So as collision occurs, force must act. And we know that resultant force is equal to change in momentum by change in time. So since force acts, so there is a change in momentum. So here we can see that since the force is acting, so there is a change in momentum, and due to this change in momentum, there is a force acting due to collision. And after the collision, there is no force acting. Since after the collision there is no forces acting, so the resultant force becomes 0. So the change in momentum 0 and the momentum again reaches a constant value. Then define linear momentum. So linear momentum or momentum is the product of mass into velocity. So momentum is the product of mass into velocity. Then use figure 2.2 to determine the time interval over which the blocks are in contact with each other. From figure 2.2, we need to determine the time interval for which the blocks are in contact with each other. So initially, y is stationary. Since we have given that y is stationary and we know that momentum is equal to mass into velocity, so as y is stationary, so its velocity is 0. Since the velocity is 0, so the momentum of y is 0. So initially y is stationary, so the momentum is 0. And as collision occurs between x and y, there is a change in momentum. So as collision occurs, there is a change in momentum. So there must be a change in momentum. And so as collision occurs, there is a change in momentum. So here we can see that there is a change in momentum, or as collision occurs, the force acts on the objects. So the resultant force acts on the object, and we know that resultant force is equal to change in momentum by change in time. So as collision occurs, there must be some resultant force. So since there is some resultant force, so there is a change in momentum. So we need to find that the time at which the blocks are in contact. That means since the blocks are in contact, so there must be some force acting when they are in contact. So since force is acting, so there is a change in momentum. Force is acting, there is a change in momentum. So there is a change in momentum from 60 time t is equal to 60 millisecond to time t is equal to 100 millisecond. So 60 to 100 millisecond. So what is the difference in time between the time interval? So that is 40 millisecond. So for 40 millisecond, the blocks are in contact with each other. So for 40 millisecond, the blocks are in contact with each other. So the force is acting, and since force is acting, so there is a change in momentum. And here we can see that there is a change in momentum. So the force is acting, therefore the blocks are in contact for 60 to 100 seconds. That is a time interval of 40 seconds, 40 milliseconds. So 40 milliseconds. Then describe without calculation the magnitude of acceleration of block Y from time t is equal to 80 millisecond to time t is equal to 100 millisecond. So we don't need to give a calculated value or the numbers such as 8, 10. Instead, we need to just state whether it is constant, increases or decreases. So what is the magnitude of acceleration? So from 80 to 100 millisecond. So from 80 to 100 millisecond, here we can see that for block Y, the momentum, there is a change in momentum. So we know that resultant force is equal to change in momentum by change in time. Also we know that resultant force is equal to mass into acceleration. So from 80 to 100 millisecond, here we can see that there is a change in momentum. Since there is a change in momentum, so there must be some resultant force. And since there is a resultant force, so there must be some acceleration. So acceleration has some value. And here we can see that the gradient of the momentum time graph is the resultant force. So for example, the gradient of displacement time graph is velocity. Similar to that, the gradient of momentum time graph is the resultant force. So gradient of momentum time graph is the resultant force. So here we can see that the gradient is constant. Since the gradient is constant, so the resultant force is constant. And since the resultant force is constant, while the mass is same, so the acceleration is also constant. So for momentum time graph, here we can see that the gradient is constant. Since the gradient is constant, so the gradient of the momentum time graph is the resultant force. So resultant force is constant. And since the resultant force is constant and the mass is same, so the acceleration is also constant. So what is the acceleration? Acceleration is constant. And what happens to the acceleration from 100 to 120 millisecond? What is the acceleration from 100 to 120 millisecond? So from 100 to 120 milliseconds, so 100 to 120 millisecond. So here the gradient of the momentum time graph is 0. So we know that resultant force is equal to change in momentum by change in time. And we also know that resultant force is equal to mass into acceleration. So here we can see that the gradient of momentum time graph is the resultant force. So here we can see that the gradient is a horizontal line. And since the gradient is a horizontal line, or the gradient is 0. Since gradient is 0, so the resultant force is also 0. So the resultant force is 0. And since the resultant force is 0, mass is constant, so acceleration is also 0. Resultant force is 0, therefore acceleration is also 0. So what happens to the acceleration? The acceleration is 0. Use figure 2.2 to determine the magnitude of the force exerted by block X on block Y. So we can calculate the force, that is force is equal to change in momentum by change in time, since we have given the momentum time graph. And we need to determine the magnitude of the force exerted. So magnitude of the force exerted. So first of all, what is the magnitude of the force exerted? So for magnitude of the force, that is the force exerted. So the force is exerted when they are in contact with each other. For example, two objects that are far apart are not in contact, so no force is exerted on them. Otherwise, they are electric or magnetic charge. But here we can see that for these two objects, when they are in contact with each other, then the force is exerted. And when the objects are in contact with each other, so the objects are in contact with each other from 60 to 100 millisecond. So at this point, the objects are in contact with each other. So at this time interval, the objects are in contact with each other. So here the force is exerted. So what is the force? So force is equal to change in momentum by change in time. So change in momentum, what is the final momentum? Final momentum is 0.50. So resultant force is equal to change in momentum by change in time, and the final momentum is 0.50 minus the initial momentum, that is 0, by change in time. So 60 minus 100, 100 minus 60, that is 40 millisecond, and milli means 10 to the power minus 3 seconds. So 0.50 by 40 into 10 to the power minus 3. 0.50 by 40 into 10 to the power minus 3. So the force that we get is 12.5 or approximately 13 Newton. So we must give our answer to two significant figure, that is 13 Newton. Then on figure 2.2, sketch the variation of momentum of block X with time from time t is equal to 0 to time t is equal to 160 milliseconds. That will be the momentum time graph for X from 0 to 160 millisecond. So for object X, I have drawn the momentum time graph for object X. That is for object X. So here for the momentum time graph, so for object X, I've drawn the momentum time graph. And so for X, we know that initially it has a momentum of 0.40 kg meter per second. So initially before the collision, so collision occurs at this time. So before collision, it has a momentum of 0.40. So initially it has a momentum of 0.40 before collision. And we know that momentum is always conserved. Momentum is always momentum is always conserved, and since momentum is always conserved, so the momentum before collision must be equal to the momentum after collision. So the momentum before collision is equal to momentum after collision, as momentum is conserved. So what is the momentum before collision? So initially x has a momentum of 0.40, so 0.40, and y is at rest, so its momentum is 0. So here we can see that y is rest, so its momentum is 0, is equal to the final momentum or the momentum after collision. So momentum before collision is equal to momentum after collision. So what is the momentum after collision? So we know the momentum after collision for y, that is 0.50. So for y it is 0.50, but what is the momentum for x? So we consider this as momentum x, that is px. So what is the momentum of x? Momentum of x is equal to 0.40 minus 0.50. So we get a value that is negative 0.10. So it is negative 0.10. So the final momentum for x, that is after collision, is negative 0.10. So negative 0.10. So if we join the two lines, then this is the change in momentum, and initially this momentum and finally this momentum. So again, if we just recall, then momentum is always conserved. And since momentum is conserved, so momentum before collision must equal to momentum after collision. And before collision, we know that the momentum of x, that is 0.40, y is at rest, so momentum is 0. So momentum is 0. And after the collision, so after the collision, we have given the momentum of y. So what we have given the momentum of y as 0.50. So 0.50. So what is the momentum of x after collision? So we consider this as px, as the momentum of x after collision. So what is the value of px? So px is equal to 0.40 minus 0.50, that is negative 0.10. So this is the final momentum for block x. So block x, the final momentum is negative 0.10. And if we join the two lines, then this is the graph for x. There is a momentum time graph for x.